Welcome to Gargoyle Canyon in California, right off Highway 78 near the California-Arizona border. The Colorado River's out here in the flats, can't quite see it, but that's our location today. Thanks for joining me for this really special field trip. I'm geology professor Shawn Willsey, and today's video is really a stroll down memory lane for me. I taught at Blvd College, which is about 20-30 minutes north of here, for 2 years in my late 20s, my first full-time teaching position. And this was one of the locations I brought students on field trips. So it's pretty cool to come back here after 20 years. My geology might be a little bit rusty here, but that'll make it fun. We'll explore it together, learn what we can, and see if we can piece some things together. Like any good field trip for teaching purposes, this one has a lot of layers to it. It has multiple chapters, different geologic events, different rock types, structures. So I think you'll find this quite a treat. So let's go ahead and head up. We'll, I guess, start here near the mouth of Gargoyle Canyon, looking at some of these whitish rocks. Let me get down to the wash here and we'll explore these in some detail, and then we'll do a couple other segments as we work our way up the canyon. Gargoyle Canyon ends up turning into a fairly narrow slot, so even geology aside, it's a pretty cool little spot to spend some time. Okay, so we've got these light colored white cream rocks here, and they are somewhat interbedded with other layers that are composed of large chunks of existing rocks. A couple cool relationships we can glean here. You can actually see right up here that the white rocks are draped up and over this one large boulder right here. So suggesting that it was deposited directly on it, you know, and it built up over the top of it. So let's look at these white layers in a little bit more detail. A lot of the little holes you're going to see here, that's just organisms burrowing in. It's probably some sort of insect or something that burrows into it. So that's not part of the rock layers themselves. They're just exploiting some of the softer layers. So we look at this stuff, it's exceptionally fine-grained. Break off a fresh piece here. A little bit more gray when we look at it in a fresh surface. And these rocks will react very vigorously to the hydrochloric acid. So calcite is the dominant material that we see here. They're quite well bedded. We can see the distinct layers here. And the age of these rocks, turns out it's Pliocene in age. So they're about, 4 to 5 or so million years old. These are mostly carbonate rocks, different types of limestones or limestones mixed with some sand or other sediment types here. And then we can see that interrupting these layers of limestone, carbonate material, there were larger events, different events that deposited a whole diversity of rock sizes and shapes and maybe even rock types. So this is probably some, you know, big flash flooding event, maybe a mass wasting event, and then we go right back to the white layers up above. So if you know a little bit about this lower Colorado region, the Gulf of California, which is what the Colorado River feeds into, it extended up into this area during the Pliocene. So this would be the Colorado River entering the Gulf of California. These are marine sediments, mostly. They've been interpreted as such, feeding into these. But then you also have the clasts and the large rocks that are being shed off the nearby mountains here, the Mule Mountains just to the west. So let's keep track of these light colored rocks as we go up. I'll probably do a separate video on these Pliocene rocks because there's a lot of controversy, and they're a pretty important rock unit in deciphering some of the history of not just the Colorado River, but also the Grand Canyon. So let's work our way up, headed to the west, and see what other observations and relationships we can glean from these units. You might even be able already to see that this Pliocene white buff colored unit capping the rim there, that as we look up towards the west, it appears to thin a little bit. And if these indeed were marine rocks thicker to the east where the Colorado River is, that it makes sense that they should indeed thin as we move to the west, and these marine rocks then would lap up onto the foot of the mountain there. We'll head up a little bit further. Probably won't be able to do a continuous video because of the walking in between, but we'll do our best to show you most of the highlights as we move up. So you can already see them thinning a little bit. Some of that's erosional, of course, from erosion from the top down. And if we look over here towards the south side of the wash, lighting might not be great. We might be able to see that it's thinning a little bit there as well. But let's head up to this next prominent point and make a few observations there. And then as we head up the canyon, you'll see it get quite narrow. It'll fork. If I remember right, there's a pronounced fork in the canyon. We'll head up the right fork, or I guess the north fork. That's the one I used to take students up. And then we'll see some other features up there. So again, first time back in 20 years. So quite the trip down memory lane. So here we have the Pliocene unit capping this outcrop, but everything underneath it looks like a hodgepodge mixture of rock sizes and shapes. It is still bedded, but a little bit more crudely, and we can see that there's definitely zones where the rock sizes are larger, and then other zones where they're much smaller. So that reflects energy levels. So as the whatever's moving the particles along, if it has more energy, it's going to move larger material. If it's less energetic, slower flow perhaps, then it's moving the smaller particles. So these are very likely regular flooding deposits coming off the mountains. We're just seeing that reflected there, and that would all be during maybe preceding the deposition of those white Pliocene units sitting up above. So I'm going to go ahead and conclude this little segment, but I'll pick it back up when we get up a little further where the canyon narrows. So we're almost near the start of the narrows, but looking back down canyon, we can really see that white Pliocene carbonate unit thinning to the right, to the west, as it caps these flood deposits. So a nice little view there of that relationship we talked about previously. And then just up ahead is where it starts to get a little bit more narrow, where the canyon starts to cut more uniformly through this material. Now these slot canyons will form anytime you have a rock unit that behaves pretty much homogeneously. So it's more or less uniform in terms of how it's eroded. It doesn't have usually a lot of layers to it, like hard and resistant layers. It's pretty uniform throughout. And so in southern Utah and other places, it might be a sandstone, but it is quite common to have rocks like these, especially in these desert environments with these high gradient streams and the weather patterns producing flash floods, to get these narrow, sometimes slot canyons incised in these types of rocks. So again, here's some of the walls of the material we're looking at. One thing I've noticed since our last little segment is the size of the class is getting a lot bigger. So that's a little bit bigger than probably basketball size. And that makes sense because as we move west, we're getting closer to the mountains, which is the source of the material. Here's a really big chunk sticking out of the wall of the canyon. So that's maybe probably across this way, that's close to a meter, about 3 feet. So that gives you a little sense of the energy it takes to transport these. Of course, these would have been transported on a sloping plain headed to the east towards the river, and then later streams have cut into these deposits to form the canyon. You can see some of the holes where some of the clasts or rocks have weathered out. Still see some crude layering here, so we can see some bedding. Overall, just gently dipping to the east, reflecting the original, I guess, gradient or slope that existed at the time these rocks were deposited. So it's not a super narrow canyon, but it's, like not necessarily a slot, but it's a nice little narrow canyon. Walls here probably maybe about 10 meters, 30-ish feet deep in this location. And pretty easy walking, not technical. I've been through canyons very similar to this in Death Valley. I think I did a video on 1 or 2 of those, so you can check those out. We'll talk more about slot canyons forming. Then we get these big chalk stones that have fallen off the walls and been transported. But you can see how smooth the floor of the canyon is, where it's solid rock, just from the abrasive action of all this rock debris when this thing floods. And maybe on average once or twice a year you might get a big enough flood to transport sediment down this. Just depends. It's a very volatile climate. It's very hot down here for much of the year, but they can get heavy rainfall events. So again, a nice view of different pulses of energy, a thick layer, well, a layer, maybe not super thick, about a half a meter or so, a couple feet of larger material. And then right above it, you see it's much finer grained. And so we're seeing those pulses of energy changing as all this material was deposited. Big chalk stone that fell here. A couple more big ones here. And then looking ahead, looks like it gets even more narrow. And if I remember right, and again, 20 years away from this place, the mind plays tricks on you, we should start seeing some other rock types. So here it gets pretty narrow, but just enough to get through. So same rock types through here. Here we go. And then just ahead, I'm seeing something a little bit different. So let's check this out. So here we have the same sand and gravel conglomerate. I guess that's what we could call it. We didn't really talk about names for these things, but sitting up above, but now it's sitting on different material, a different rock type. So we've got a nice pronounced contact that runs through the canyon. On this side, kind of comes up and down. And as we look at these rocks, this side, they're gray. There's little black specks, little crystals in here. So these look like these are volcanic rocks. And based on the minerals I'm seeing in here with some of these long, black, skinny hornblende crystals and a little bit of white, there's some white plagioclase feldspar in here as well. I would right now call this an andesite. So this is volcanic rock, andesitic lava, and we've got that surface eroded. So we're looking at an erosional surface here that these sands and gravels, this conglomerate, was then deposited on. So really nice contact there between these two different units. And what'll be interesting to see is how the canyon changes character going up now that it's cutting into this harder rock. You can already see that the floor of the canyon has shifted from more or less the middle of the canyon, it's deflected over here because this is where the softer material is. So let me grab my notebook and rock hammer, and let's head up a little bit further. Obviously some birds have been in here. Okay, and here's the fork that I remember. Oh, here's, you guys want to see a little biology? From these slot canyons, not much living, but here's a little toad. Just waiting for the next rainfall event to get a little moisture. So you see these a lot in some of these canyons. Okay, so up the andesite. So the main stem of the canyon goes that way, but we're gonna scramble up here. We can see that there's some white stripes cutting through the andesite, little thin veins of material. And if we head up a little further, this is so fun to come back to after so many years away. Here we have a big pothole. So there's a little bit of a dry fall here where the water comes off and has excavated a good sized pothole. But if I remember right, the real star of the show here is why this dry fall is here and what we see in the walls. So if we look up at this dry fall, you might see how smooth and polished these rocks are. Just exceptionally polished here. And if we look right here, we can see, remember we're in the andesite, right? This is the andesitic lava, but here we see the rocks are broken up into chunks. They're angular. It looks like a breccia. And with that polished surface right there next to it, and these busted up fragmented rocks that aren't very thick, right? You can see they're only maybe a few inches or centimeters thick from this wall to this wall. The reason that there's a dry fall here and the structure we're seeing here, and we can actually project this surface, which is running this way. If we take it over to the opposite wall, you can see a nice color contrast between the gray rocks on the right and the more brown rocks on the left. This is a fault. We're looking at a fault plane that has shifted the rocks up and down, and this is what we would call a fault breccia. This is the pulverized rocks that exist right along the fault plane due to the movement along the fault. And these smooth surfaces, they do have a hint of lines on them. These are what we call slicken lines. They actually record the direction of motion along the fault plane. I'm gonna actually try to scramble up there and see if we can look at it from up there. There may be a secondary fault here. Oh yeah, I think there is. So notice we've got, back up a little bit so you can see this. There's a bit of a, it's kind of facing you here, but there's another break here between this unit and this one. And so we have a pretty smooth surface here with some lines running across it more or less this way. They do extend up onto this face here. So we have another fault here that shows us some of these polished faces and these slicken lines here. Fantastic. Just, this is why it was such a great field trip stop for students 20 years ago, and now with YouTube and all the great things happening, we've got another great field trip for you good folks. Yeah, awesome. Let me see if I can get up and over the dry fall. Pretty easy scramble on this side. Can't remember if there's anything super awesome at the top, but it'll give us a little bit of a perspective to be able to look down. Okay, so now we can see, oh, this is great. So now we're looking down at the fault plane. Let me get you a little bit closer. Some of you are freaking out because of the exposure. I feel very safe. But here's one side of the fault, what we would call the footwall. There's the opposite side of the fault. And then this, 2-inch, maybe 4 to 5 centimeter layer of fault breccia. We can actually trace that as a seam over to here, where you can see it contrasting between, again, the footwall rocks. There's our fault and the fault breccia, and then the rest of the lava flow there. There's apparently been some mineralization of some of this material here. You can see some of the white matrix cement that's kind of gluing all that together. Yeah, that's calcite. So I'd expect there to be quite a bit of calcite in here, knowing we've got those carbonates nearby. And then you can see, looking up a little bit further, some of this andesite, which is really kind of busted up with these veins. And then going up a little further, the canyon starts to open up. But we still have that contact, right, with our andesitic lava and our conglomerate sitting on top. Here's a nice view of the andesite with some of the plagioclase, feldspar crystals. Here it's a little bit more brecciated. It's broken up a bit, possibly due to the fault movement. But then it looks like things open up going up that way. And the thickness of our unit on top, or conglomerate, gets a little bit thinner as well. But a nice view there of the contact on each side of the canyon, looking down, so we can see the andesite conglomerate contact on either side. And then the water is cut down through this material, which is hard. These rocks, these andesites, are hard, but this big significant drop where the big pothole is partially exists because of the fault that has moved one side down relative to the other, and possibly due to the fact that the rocks have been pulverized along that zone, so maybe they're a little bit softer. But we can see this fault dipping away from your view, extending from this side of the canyon over to here. So it's dipping down the canyon in that direction. Pretty exquisite, pretty awesome. So, wow. Maybe I enjoyed that as much as anyone, because this was a place I used to bring students to when I was brand new in my teaching career, and we had a handout and they had to make observations, figure things out. This was an assignment. This was one of our field trips that we regularly did. So I hope you enjoyed this. I hope you enjoyed exploring Gargoyle Canyon here in southeastern California, right near the Colorado River. This exquisite landscape. Geology is just well displayed here. So fun to get in here and look at things with you. So thanks for joining me. Appreciate you sharing, subscribing. And if you want to donate, there's a thanks button below the viewer. And there's also links under the video description if you want to make a donation to help my cause in producing geologic and educational videos. So thanks so much. And we'll see you next time from Gargoyle Canyon.